So far we've only looked at simultaneous move games and very briefly at repeated simultaneous move games. Now let's look at some sequential games. So what if players take turns rather than moving at the same time? If this is the case, very often the game can be solved by what's called backwards induction. And so this is actually really good chess players are really good at backward induction. And this is basically the process of deducing backwards from the end of a scenario to infer a sequence of optimal actions. So what's my best course of action? Working backwards from the end. So that's backward induction. Okay, let's start with this example here. So this is a simultaneous move game. That's why it's represented in a table. So let's see. Let's start off with Azalea. What are Azalea's best choices here? Let's assume that Iggy agrees. What is Azalea's best option? So if she chooses disagree, she would get 35,000. If she chooses agree, she would get 60,000. So if Iggy chooses agree, Azalea's best option is to also agree. Okay, so that's what we see there. What if Iggy instead disagrees? Well, in that case, Azalea's best choice is to also disagree, right? 75,000 versus 50,000. Okay, so these are the best choices. These are the best responses for Azalea. Okay, what about Iggy's best responses? If Azalea agrees, what's the best thing for Iggy to do? The best thing for Iggy to do is disagree. So that's Iggy's best response, is to disagree if Azalea agrees. What if Azalea disagrees? Well, then Iggy's best response is to agree. Okay, so these are Iggy's best responses. Now, as we can see here, we don't have a box where both outcomes are circled, so there's actually no Nash equilibrium in this game. This is an unstable game. There's no Nash equilibrium. Pick any box, and one of the players will want to change their choice, right? So if we started here in this box, then Iggy wants to change from disagreeing to agreeing, right? And if we ended up here, then Azalea wants to change from disagreeing to agreeing. Okay, so as it turns out, there's no stable point in this game. There's no Nash equilibrium. But what if it was a sequential game instead? So with sequential games, we represent them with what's called a game tree, because it kind of has these nodes and branches, kind of like a tree. And so down here are the outcomes, are the various outcomes. You'll note that Azalea's payoff is the first one, since she's the first mover, and Iggy is the second payoff in these pairs because Iggy is the second mover. Okay, so Azalea moves first. Her choice is to agree or disagree, and then after that, Iggy moves next, and depending on what Azalea chose, Iggy decides to agree or disagree, right? So if Azalea agreed, Iggy would then decide to agree or disagree, and these would be the possible outcomes in that case. Or if Azalea disagreed, Iggy would then choose to agree or disagree, and these would be the possible payoffs here. Okay, so let's do some backward induction, okay? Okay, so let's start off by assuming that Azalea agrees. Well, if she did that, she knows that Iggy would then have these choices here and get these payoffs here and here. And of course, given that she agrees, if she were to agree, she knows that Iggy would choose to disagree because 75,000 is better than 20,000. So she knows that Iggy would not choose to agree on this branch of this game tree, right? So that's where she would end up, right? If she chose to agree, she would end up with $50,000 because she knows Iggy would not agree, he would disagree. What if Azalea instead chose disagree? Well, in that case, she knows that Iggy would choose to agree because $50,000 is better than $25,000. Okay, so in that case, disagree for Iggy is eliminated over here. All right, so Azalea knows that if she chose to agree, she would get 50,000. If she chose to disagree, she'd get 35,000. So what does she want to do? Obviously, 50,000 is better than 35,000. So for for Azalea, disagree is eliminated. So we just conducted backwards induction. Working from the end backwards, Azalea figured out that her best choice is to agree, because if she agrees, she knows that Iggy is going to disagree, and she's going to end up with $50,000. Okay, and there's no way for her to get to this outcome here or this outcome here. So that's the process of backwards induction.